imagine a world where AI is helping us make like fairer decisions. Sounds awesome, right? But what if the AI itself is biased?
Yeah, that's a huge problem.
That's what we're tackling in this deep dive. It's the surprisingly complex world of AI fairness.
Definitely complex.
We'll be using this workbook as our guide,
Okay.
created by experts at the Alan Turing Institute. It's called AI Fairness in Practice.
Oh, yeah, I've seen this.
Yeah.
Really interesting stuff.
Yeah, it's really cool. And think of this deep dive as your crash course on how AI bias creeps in and crucially what we can do about it.
Yeah, it's a really valuable resource, because it highlights that fairness issues can pop up at any point in like an AI project.
Oh, totally.
It's everything from the initial idea to how the data is collected, how the model is built, and even how it's used by people in the real world.
Yeah, okay, so before we even get to like biased algorithms, let's talk about why fairness itself is such a tricky thing to define.
Right.
The workbook actually points out there are tons of different interpretations of what fairness means.
Oh, yeah, for sure.
For example, one definition focuses on treating everyone equally,
Right.
while another emphasizes achieving equitable outcomes, even if it means treating some groups differently.
It's true. And that's a big part of what makes building fair AI so challenging. Because we don't have a universal agreement on like a single definition. So how do we build an algorithm that embodies, fairness if we don't even know what it is?
Right. It's like trying to hit a moving target.
Exactly.
In the dark. But even though fairness is hard to pin down, we can all agree that discrimination is a big problem.
Huge.
And unfortunately, AI has the potential to repeat and even amplify the inequalities we see in the real world.
Exactly. Even if we don't intend for it to happen, AI can disadvantage certain groups. We could be talking about race, gender, socioeconomic status, all kinds of things.
And the workbook has some real-world examples of this. They're pretty mind-blowing.
Oh, really?
There's this case of an AI for cervical screening that unintentionally left out transgender patients because it was trained on data that mainly categorized patients as just male or female.
Oh, wow. So a transgender man who still has a cervix might not have been flagged for screening because the system just didn't account for their situation.
Exactly.
Wow.
That's a really stark example of how data fairness can make or break an AI system. Even if the algorithm itself is unbiased, if the data you feed it is flawed, you're going to end up with biased outcomes.
It's true. It's like trying to bake a cake with only half the ingredients.
Right.
It might look like a cake, but it's not going to taste quite right. And in this case, we're talking about something far more serious than a bad cake. We're talking about potentially delaying or missing crucial cancer screenings for a whole group of people.
It really highlights how these issues of AI fairness have real-world consequences for people's lives.
For sure.
It's not just an abstract concept. Here's where it gets even crazier.
Okay.
We're also going to look at a radiology AI that learned to predict a patient's race just from medical images. Makes you wonder, how can an AI learn something we didn't even mean for it to learn? What did that even mean ethically?
It's a bit unsettling, right? This case really highlights how AI can perpetuate biases we might not even be consciously aware of. And that's why the Alan Turing Institute breaks down AI fairness into 6 key areas.
Okay.
They call it data fairness, application fairness, model design and development fairness, metric-based fairness, system implementation fairness, and even ecosystem fairness.
Okay, let's unpack that. So data fairness, that seems pretty straightforward.
Yeah.
You're talking about making sure the data itself isn't biased or missing important info, right?
Exactly. And it's about more than just having enough data points. It's about ensuring the data accurately reflects the real world and the people the AI is meant to serve.
So what about application fairness? That sounds more like a philosophical question than a technical one.
It is. It gets to the heart of whether we're using AI for something that people consider fair and ethical. Take facial recognition technology. We could use it for security purposes, but some people argue that using it for mass surveillance crosses an ethical line.
Yeah, I see what you mean. So even if the AI itself is technically fair, the way we apply it can raise ethical concerns. What about model design and development fairness? I'm guessing that's all about building the AI in a way that avoids those baked-in biases we were talking about.
That's right. It's about being really thoughtful about what features the AI uses to make decisions, how it's trained, and being on the lookout for any unintended consequences.
Then there's this whole idea of metric-based fairness, which sounds pretty technical. How do we even measure something like fairness when it can be so subjective.
Yeah, that's one of the biggest challenges in this field, for sure. There are all these different fairness metrics out there, each with its strengths and weaknesses. And figuring out which one is best really depends on what the AI is doing and how it could impact different groups.
So it's not a one-size-fits-all situation. And what about system implementation fairness? That sounds like it has more to do with the humans involved, right?
It absolutely does. This area focuses on how people are trained to use the AI and how to prevent new biases from popping up when people interact with the system. For example, we want to make sure doctors aren't just blindly trusting an AI's diagnosis without considering their own knowledge and the patient's individual circumstances.
Oh, wow. Yeah, that's a bit scary to think about.
Yeah.
Too much trust in AI could definitely lead to problems. Okay, so we've covered data, application, model design, metrics, and system implementation fairness. That leaves us with ecosystem fairness. What does that even mean? Is the weather fair for AI development today?
Lex, I had to. Not quite. Ecosystem fairness means taking a step back and looking at the bigger picture. It's about the systems around AI, like research funding, data access, and the diversity of the people building these technologies. Are those systems themselves fair and equitable?
So it's about making sure the entire landscape is set up in a way that promotes fairness, not just the AI itself.
Exactly.
That makes a lot of sense. And it sounds like the Alan Turing Institute really takes this holistic approach. They even have a bias self-assessment template to help identify potential problems before they become a big deal. It's like a checklist to make sure fairness is considered at every step of the way.
Exactly. And it walks you through thinking about all these different areas of fairness we've been talking about. It prompts you to consider potential sources of bias, assess your project's vulnerabilities, and brainstorm strategies to mitigate those risks. It's a really practical tool.
It sounds incredibly helpful. I'm sensing a theme here.
What's that?
Awareness is key. We need to be constantly on the lookout for potential bias in AI and work actively to mitigate it.
I completely agree. It's not enough to just hope for the best. We need to be proactive and intentional about building AI that's fair and equitable for everyone.
Well said. Now let's get into some of those mind-blowing examples of AI bias that I mentioned earlier.
Okay, let's do it.
First up, we have the case of the cervical screening AI that missed a crucial group of people. Stay tuned.
Can't wait. Okay, so let's dive deeper into that cervical screening AI that we touched on earlier.
Yeah.
This system was designed with the best of intentions to, make cervical cancer screenings more efficient and accessible to more people.
Yeah, it sounds like a perfect use case for AI. You're automating a routine task and potentially saving lives. What could possibly go wrong?
Well, the problem emerged from the data that was used to train the AI. It was primarily based on medical records that categorized patients as either male or female, which, created a blind spot for transgender individuals.
So like a transgender man who still has a cervix might not have been flagged for screening because this system didn't account for their situation.
Exactly. The system wasn't designed to consider individuals who had transitioned and, whose gender identity didn't align with the sex that was recorded in their medical records.
That's a really stark example of how data fairness can make or break an AI system. Even if the algorithm itself is unbiased, if the data you feed it is flawed, you're going to end up with biased outcomes.
Absolutely. It's like trying to bake a cake with only half the ingredients.
Right.
It might look like a cake, but it's not going to taste quite right. And in this case, we're talking about something far more serious than a bad cake. We're talking about potentially delaying or missing crucial cancer screenings for an entire group of people.
It really highlights how these issues of AI fairness have real-world consequences for people's lives.
Yeah.
It's not just an abstract concept.
Exactly. And it really underscores the importance of having diverse and inclusive teams working on AI development.
Oh, for sure.
Having people with different perspectives and lived experiences can really help to catch these kinds of biases early on.
Yeah.
Imagine if there had been a transgender person on the team developing this cervical screening AI, they might have been able to flag this issue before it even got to the testing phase.
Totally right. It's about having those different voices in the room, asking those tough questions, making sure everyone is considered. That brings us to another key area of AI fairness, application fairness.
Right.
Even if an AI is technically accurate and efficient, we need to ask ourselves, is it being used ethically and responsibly?
Yeah, a perfect example of this is the case of the radiology AI that could predict a patient's race from medical images.
Oh, wow.
It's a fascinating example of how AI can uncover patterns that we humans might not even be aware of.
It's kind of mind-blowing, isn't it? It's like the AI is seeing something in those images that human radiologists are missing. But the question is, should it be seeing that? What are the ethical implications of that kind of knowledge?
That's the dilemma. On the
Hmm.
one hand, this kind of discovery could potentially lead to new medical insights.
Yeah.
Maybe there are subtle differences in anatomy or disease presentation that correlate with race, and that could be valuable information for doctors.
But on the other hand, it's not hard to imagine how this information could be misused or misinterpreted to further entrench racial biases in healthcare.
Oh, totally.
What if an insurance company uses this AI to predict a patient's risk of certain diseases and then denies coverage based on race?
That's a real concern, and it really underscores the need for careful consideration and, open discussion about the potential consequences of using AI in really sensitive areas like healthcare.
It's like opening Pandora's box. The potential for both good and bad is just enormous.
Right.
And it seems like the best way to navigate these ethical gray areas is to just keep asking those tough questions and, having those difficult conversations.
Absolutely. And this brings us back to that idea of model design and development fairness.
Okay.
How can we actually build AI systems that are less likely to exhibit these kinds of biases in the first place?
Right.
How do we bake fairness into the very DNA of the algorithm?
Right. It's not enough to just be aware of the problem. We need to come up with practical solutions. So what are some of the concrete steps we can take to build more equitable AI?
Well, the Alan Turing Institute's workbook lays out several key principles, and one of the most important is careful consideration of the features the AI will use to make decisions.
Yeah.
We need to be really mindful about what information is truly relevant to the task at hand,
Yeah.
and what information could potentially introduce bias.
So going back to that radiology example, if we're building an AI to diagnose a specific disease, the patient's race shouldn't be a factor in that decision.
Exactly. But even if we exclude race as an explicit feature, the AI could still pick up on subtle proxies for race if it's trained on biased data.
Hmm.
For example, certain zip codes might be predominantly populated by certain racial groups.
Right.
If the AI has access to a patient's zip code, it could potentially infer their race, even if that information isn't explicitly given.
It's like the AI is playing a game of guess who and using any clues it can find to figure out the person's identity. But those clues might be based on stereotypes or historical biases.
Yeah.
So how do we prevent that from happening?
That's where things like data preprocessing and feature engineering come in. We can take steps to remove or anonymize potentially sensitive information from the data before we feed it to the AI.
Okay.
And we can also use techniques like data augmentation to create more balanced data sets that better represent the diversity of the real world.
So it's about being really intentional about what we teach the AI and how we teach it.
Exactly.
But even if we're careful about the data and the features we use, there's still a risk that the AI could learn unintended biases during the training process. How do we address that?
That's where techniques like adversarial training come in. It's kind of like setting up a sparring match between two AIs.
Oh, interesting.
One AI is trying to learn the task at hand, let's say making accurate diagnoses from medical images.
Okay.
The other AI is specifically trying to identify and exploit any biases in the first AI's predictions.
So it's like having a built-in bias detector that's constantly challenging the AI to be more fair.
Exactly. And by pitting these two AIs against each other, we can force the first AI to become more robust and less susceptible to bias. It's a really clever approach.
That's fascinating. It seems like there's a whole arsenal of tools and techniques we can use to make AI more equitable, but it also sounds like it requires a lot of expertise and vigilance on the part of the developers.
Absolutely. Building fair AI isn't a one-time fix. It's an ongoing process of testing, refining, and iterating.
Yeah.
We need to be constantly evaluating our systems, looking for potential biases, and, taking steps to mitigate those risks.
It's like any skill practice makes perfect. The more we work at building fair AI, the better we'll become at it. And it's encouraging to know that there are organizations like the Alan Turing Institute that are developing these resources and frameworks to help guide us on that journey.
Exactly. And the good news is that we don't have to reinvent the wheel every time. There are already established best practices and tools like the bias self-assessment template that we can use to make our AI systems more fair and equitable.
Speaking of the bias self-assessment, let's dive into that a bit more.
Yeah.
It sounds like a really practical and useful tool for anyone working on AI. How does it actually work? What kinds of questions does it ask?
It's designed to be very user-friendly and applicable to a wide range of AI projects. It starts by prompting you to think about the different types of bias that might be relevant to your specific project.
Okay.
They even have this helpful taxonomy of biases that breaks them down into categories like data bias, design bias, and even ecosystem bias, which we talked about earlier.
Right, ecosystem bias, those bigger picture societal factors that can influence AI development. So the self-assessment helps us to broaden our perspective and consider all those different levels of potential bias. What happens next?
Then it guides you through a series of questions that help you assess your project's vulnerabilities to those biases. For example, if you're building an AI system for hiring, the self-assessment might ask, what data are you using to train the AI? Does it represent a diverse range of candidates, or is it skewed towards people who fit a certain profile?
Right back to data fairness. If your training data is biased, your AI is going to learn those biases. It's like teaching a kid to read using only books about one specific culture. They're going to have a limited and potentially skewed understanding of the world.
That's a great analogy, and the self-assessment helps you to catch those potential biases early on so you can take steps to mitigate them. But it's not about throwing out the whole project if you find a potential bias. The real power of this tool is that it focuses on risk mitigation and finding practical solutions.
So once you've identified a potential bias, what are some of the strategies the self-assessment suggests?
There are a lot of different approaches depending on the specific bias and the context of your project. One common strategy is to carefully curate your training data, making sure it's representative of the population the AI is intended to serve.
So in our hiring example, you might make an effort to collect data from a more diverse pool of candidates, or you might use techniques like data augmentation to artificially create more data points to balance out any imbalances in your existing data set.
Exactly. It's about giving the AI a more well-rounded education. And there are also techniques like adjusting the algorithm itself to make it less sensitive to certain features that might be correlated with bias, for example. You might downweight the importance of a candidate's zip code in a hiring algorithm, as that could be a proxy for socioeconomic status.
So it's like tweaking the knobs and dials of the AI to make it more fair and equitable. It sounds like this self-assessment is a really valuable tool for thinking through these issues and coming up with practical solutions.
It is, and it encourages you to think about fairness at every stage of the process, from data collection and pre-processing to model design and development, all the way to system implementation and monitoring.
It's a holistic approach, which is exactly what we need when we're talking about something as complex and multifaceted as AI fairness. But I'm curious, even with all these tools and techniques, is it even possible to completely eliminate bias from AI?
That's a great question, and it's one that a lot of researchers and ethicists are grappling with. I think the honest answer is that it's probably impossible to eliminate all bias completely. AI systems are built by humans, and humans are inherently biased, but that doesn't mean we should just give up and accept bias as inevitable.
Right. It's not about achieving perfection. It's about striving for progress and constantly working to make our AI systems more fair and equitable. And tools like the bias self-assessment template give us a practical framework for doing just that.
Absolutely. It's about building a culture of fairness within the field of AI, where we're constantly questioning our assumptions, testing our systems, and pushing ourselves to do better. And that's a journey worth taking.
I couldn't agree more. Now, I know we've been focusing a lot on the risks and challenges of AI bias, but before we wrap up, I'd love to hear your thoughts on the potential of AI to actually increase fairness in areas where humans struggle. Is it possible that AI can help us overcome our own biases and create a more just world?
That's a really intriguing question, and I think it's one that deserves a lot more attention and exploration. There are definitely some promising examples of how AI can be used to promote fairness and equity.
Yeah, like,
For example, there are AI systems being developed to help identify and mitigate bias in hiring processes, to ensure that loans are distributed fairly, and even to help judges make more impartial sentencing decisions.
so AI could potentially act as a kind of bias watchdog, helping us to see and correct our own blind spots.
Exactly. And in some cases, AI might even be able to identify and address biases that we're not even consciously aware of. But it's important to remember that AI is a tool. And like any tool, it can be used for good or bad. The ultimate responsibility for creating a more just and equitable world still lies with us.
That's a crucial point. We can't just offload our ethical responsibilities onto AI.
Right.
We need to be thoughtful and intentional about how we design, develop, and deploy these technologies, and we need to be constantly vigilant about the potential for bias, both in the AI systems themselves and in the ways that humans interact with them.
I completely agree. And that's why it's so important to have these conversations, to share knowledge and resources like the Alan Turing Institute's workbook, and to work collaboratively towards building a future where AI is used to promote fairness and justice for all.
Well said. This has been a truly insightful deep dive into the complexities of AI fairness, and I think the key takeaway for me is that building fair AI is an ongoing process that requires vigilance, creativity, and a deep commitment to ethical principles.
I couldn't have said it better myself. It's a challenge, but it's a challenge worth embracing.
Absolutely. And I think that's a great note to end on. Thanks for joining us on the deep dive. All right, so we've talked about the risks and challenges of AI bias, but now let's get practical. What can we actually do about it?
That's the big question, right?
This is where the Alan Turing Institute's bias self-assessment template comes in.
Oh, yeah, this is a good one.
Have you used this before?
I have. I really like this tool because it walks you through a step-by-step process for spotting those potential biases. And it does this at every stage of your AI project. Think of it as a checkup for your algorithm.
I love a checkup for your algorithm.
Yeah, like taking it to the doctor
Okay.
to make sure everything is running smoothly.
Okay, so walk us through it. How does this self-assessment actually work?
Well, the first thing it does is prompt you to think about different types of bias that could be relevant to your project. And they even have this handy taxonomy of bias that breaks them down into categories like data bias, design bias, and even ecosystem bias, which we talked about earlier.
Right, ecosystem bias. We talked about data and algorithms being biased, but how can a whole ecosystem be biased?
Yeah, it's a great question. Remember, AI doesn't exist in a vacuum.
Right.
Ecosystem bias acknowledges that there are those broader societal factors that can influence AI development.
Yeah.
Think about who's funding the research, who has access to the data, and even whose voices are being heard or ignored in the decision-making process.
So it's recognizing that the world around the AI can impact its fairness, even if the algorithm itself seems neutral.
Exactly. By taking those broader societal influences into account, you can start to uncover potential biases that you might miss otherwise.
Okay, so the self-assessment helps raise awareness of different types of bias. What's the next step?
From there, it encourages you to reflect on how your specific AI project might be vulnerable to those biases.
Okay.
And the template provides a bunch of questions to guide you through this.
For example, paint us a picture with a real-world scenario.
Okay, sure. Let's say you're building an AI system to help with hiring decisions.
Okay, yeah.
The template might ask, what data are you using to train this AI? Does it represent a diverse range of candidates, or is it skewed towards people who fit a certain profile?
So it brings us back to that core issue of data fairness.
Exactly.
If your training data is biased, your AI is going to learn those biases. Garbage in, garbage out, as they say.
Precisely. And the beauty of the self-assessment is that it helps you to catch these potential biases early on so you can actually do something about them.
So we've identified some potential biases. What happens next? Do we scrap the whole project?
Not necessarily. This is where the self-assessment gets really practical. It's all about risk mitigation.
Okay.
Once you've found those potential biases, you can start brainstorming strategies to address them.
Okay, so give us some examples. What are some things people can actually do to make their AI more fair?
There are tons of different approaches, and the best one really depends on the specific type of bias you're dealing with. One very common strategy is to carefully curate your training data. You want to make sure that it represents the full diversity of the population your AI is supposed to serve.
So in our hiring example, that could mean actively seeking out data from a more diverse pool of candidates.
Exactly. You could also look into techniques like data augmentation, where you basically create more data points to balance out any imbalances in your existing set.
That's a neat trick, like giving the AI a more well-rounded education, so to speak. What other mitigation strategies are out there?
Another approach is to adjust the algorithm itself. You can make it less sensitive to features that might be correlated with bias. So in that hiring AI, you might decide to downplay the importance of a candidate's zip code, since that could be a proxy for socioeconomic status.
Interesting. So we're fine-tuning how the AI makes decisions, making it more equitable in the process.
Exactly. And then there are some really cool techniques like adversarial training. This involves pitting two AIs against each other. One is trying to make accurate predictions, while the other is specifically trying to find and highlight any biased predictions.
It's like a constant battle to keep the AI honest.
That's a great way to think about it. And remember, it's not about reaching perfection. It's about being proactive and iterative.
Right.
By continually testing and refining your AI system, you can make it significantly fairer.
So it's an ongoing process like any skill.
Yeah.
The more you practice building fair AI, the better you'll get at it.
That's the key takeaway, and the Alan Turing Institute really emphasizes that fairness is not a box you check off. It's a commitment you make throughout that entire development process.
I love that it speaks of building a culture of fairness in the field of AI. You're constantly questioning your assumptions, testing your systems, and pushing for better, more equitable outcomes.
Absolutely. And the bias self-assessment template is such a fantastic resource to have along that journey.
It sounds incredibly useful for anyone working with AI. Big thanks to the Alan Turing Institute for putting this tool together.
For sure.
And to you for this super insightful deep dive into AI fairness. It's been really thought-provoking.
My pleasure. I've enjoyed it.
The big takeaway for me is this. Building fair AI is a continuous journey.
Yeah.
It demands vigilance, creativity, and a commitment to ethical practices.
Absolutely. By embracing those values, I believe we can use AI to build a more just and equitable world for everyone.
What an inspiring thought to end on. Thank you for joining us for this deep dive into AI fairness. Until next time, keep learning and keep questioning.